Welcome everyone to this lecture on the chapter of laws of motion. So we were discussing questions on the topic of friction. So let us continue. The first question which we are going to do is question number 6. So this is a very cool problem. We have an incline and the incline is carrying a mass of value m. The question states that there is a force P acting on the block which is parallel to the plane. The forces in the direction along the incline in upward direction are to be considered positive. As P is varied from the value P1 equal to mg sine theta minus mu cos theta, this is some value which we are given, to the value P2 equal to mg some sine theta plus mu cos theta. The block is held stationary, that is the whole point. So we have to draw the graph of applied force with friction. So we are given some values of P1 and P2 and we are asked that what would be the variation of friction with the applied force if the system is at rest. So upon careful analysis of the values of P1, so let's say first we are analyzing P1 only. So it contains mg sin theta and mu cos theta. So the value mg sin theta is going to balance the gravitational force which acts in downward direction, the component of its force, and the value mu cos theta is the force of friction which acts in upward direction. So as you can see, the sum of the gravitational force and the frictional force is mg sin theta minus mu cos theta, right? This is when the friction is acting in upward direction, and this is the force which is supplied by P1. So this by this what is meant is that the value of P1 is selected in such a way that the system is just not moving, right? And we have supplied the least value of P1 for which the system won't move. So we are taking the advantage of maximum value of the friction which is available to us, that is mu mg cos theta. And the same thing will happen when we analyze P2 also. In that case, we would say that the value of P2 is so high that the block is going to be driven in upward direction. So the friction would act in downward direction in that case. So in this case, in the first case, the friction was acting in upward direction, and in final case, the friction would act in downward direction because the value of P2 is so high. So what would happen if the value of P is simply mg sin theta? So if the value of P is simply mg sin theta, then we would say that friction is not required at all. The gravitational force would be balanced by the value of P, and we would say that friction is not required, or the value of friction would be 0. So if we draw the graph of friction with the value of applied force, we would say that the value of applied force P1, when the value of applied force is at P1, friction is acting in upward direction, which as stated by the question is to be taken as positive. The direction of force pointing upward is to be taken positive. So the first friction is acting in upward direction, the friction is positive. Then the value of applied force comes to mg sin theta as P1 grows from this value, and then friction won't be required. And when P1 value of P exceeds mg sin theta, friction would start acting in upward direction, in downward direction, and it would reach some maximum value. So the graph should look something like this. That is option C. Next, so the next question which we have a block, and the block is kept on a surface which is having some friction. So the value of friction which we have, coefficient of friction which we have is mu. So we have to calculate the acceleration of both the blocks. So this should be an easy one. Acceleration of both the blocks should have the same value as they are related to the same strength. Drawing the force of both the masses, we would say the tension acting on the mass M in this direction, gravitational force this. So mg minus t would be equal to mass times acceleration. And for this mass, gravitational force is acting in downward direction, normal reaction this direction, tension and the friction. Friction is acting in leftward direction as the block is being driven towards right. So we'd say for block number 1, that is this one. This is the equation, and for the second block, the Newton's second law equation would be tension minus friction, which will take mu mg as the system is sliding, and when we add these two values, we'd get mg minus mu mg is equal to 2 times ma, or we'd say g by 2 into 1 minus mu is equal to acceleration of both the blocks. Next, let us do question number 8. So a block is kept on an incline of angle of inclination on 37 degree, and we are supposed to find that what is the acceleration of the system in this case. So in this case, the decision making that the acceleration would happen along the incline in downward or along the incline upward direction, or whether it would happen at all, is not straightforward. So what we do is that we try to cut the different things affecting our system. For example, the mass 10 kg block is being affected by 4 kg mass. Here the system is here the incline is having a coefficient friction mu. So we do not know in which direction the friction would happen. So what we do is that we'll analyze this 10 kg block without any tension acting on it for a moment. So it's a 10 kg block. The gravitational force is mg, normal reaction, and the friction. Let us assume friction is acting in upward direction, and the acceleration of the block is in some downward direction. Let us assume that. So at least we can assume that when the tension is not happening on the system. So let's say the downward force acting on the system is mg sine theta minus the upward force acting on the system, that is mu mg cos theta, and that should be the net force which is driving the system in downward direction. So these values should come out to be sine theta, that is 3 by 5, minus mu, that is 0.2 into 4 by 5. So this value should come out to be mg 3 minus 0.8 upon 5. So this value should come out to be 2.2 divided by 5. So that would be the value of f, that is driving the whole system. And since this value is coming out to be positive, let us say let us find what this value is equal to. So the value of mg is 100, so this would come out to be 220 by 5, that is some 44 newtons. So this value 44 newton is greater than the gravitational force which is pulling the string in downward direction. So we say that the system is able to draw the 4 kg block in upward direction. So our assumption is correct that the acceleration of block is happening in downward direction. If the acceleration of the block we had assumed in upward direction, we would say that the friction is acting in downward direction and the 4 kg block is able to draw the 10 kg block. So it won't be happening because mg sine 37 of 10 kg block is greater than that of the 4 kg block. So that case wouldn't have happened either. So it say that the system is being driven by 44 Newton force in this direction. So and that force, 44 Newton force, will be subtracting the mass of this block mg to get the net acceleration of the system. So we would say 44 minus the gravitational force, that is 40, and net mass of the system is some 14 times acceleration. So this would come out to be 4 upon 14, or the value would be some 2 by 7 meter per second square. So that would be the acceleration of the system. So as you can see in this question, we analyzed first how to decide upon the system, right? So we decided the system which has maximum forces acting on it. So maximum forces were acting on 10 kg block. Then we arbitrarily assume that the system is going to be in downward direction. And then later we explained that okay, the 10 kg block cannot at least go in upward direction. We calculate the force which is being acting on the 10 kg block, the net force acting on the 10 kg block along the incline. So that is 44 Newton. And from that 44 Newton, we subtracted the gravitational force acting on the 4 kg mass to get the net acceleration of the system. So you would see the tension in the system, but they would simply cancel out. And the only forces which are driving the system is the gravitational force. So that helped us in getting the value of acceleration of the both the blocks. So thank you for joining and have a nice day.